We're going to be taking a look at transversals and parallel lines. So if I had two lines that were parallel, so if I had line here P and Q, in our diagram, in order to show that they're parallel, we would put these two little triangle marks onto those lines. Now if they were cut by a transversal just being a line that cuts across it, so we'll put a straight line into there, and we're going to call it T for transversal. What we need to do to be able to talk about some of these lines is we need to number their angles so that we have a way to talk about these. So I'm going to number the angles 1, 2, 3, 4, 5, 6, and 7, 8. So what we have is two angles are called corresponding angles. Corresponding angles are like angle 1 and angle 3 are corresponding angles. This lets us know that they're congruent to each other, okay? The corresponding angle theorem says two parallel lines that are cut by a transversal, which is what we have here. Then the corresponding angles are considered congruent, and I'm sorry, I misspoke, and for some reason I said 3 and I meant angle 5. We still make mistakes in this world. So when they're corresponding in position, like angle 1 and angle 5, they're called corresponding angles. They have the same general location to each other. We also have same side interior angles. Same side interior angles would be like angle 3 and angle 6. Now the thing about same side interior angles is they give us the same side interior angle postulate. And that is that if we have two parallel lines, just like here, and they're cut by the transversal just like before, then these two angles add up to 180 degrees. Alternate interior angles in this diagram would be like angle 3 and angle 5. Now the thing about alternate interior angles is this is the alternate interior angle theorem. Again, two parallel lines cut by a transversal, then these two angles are congruent. So we use this little symbol for congruent. It's like an equal sign with a squiggle on top. Then we have alternate exterior angles. Alternate exterior angles would be like angle 1 and angle 7. This is so that we have ways to talk about them all the time. Okay? If we were to realize that corresponding angles 2 and 6 have the same measure, 1 and 2 add up to 180, 6 and 7 add up to 180, that means that angle 1 and angle 7, they're congruent to each other. Now a little bit more ways of writing some things that you might need is to know that how you might say two lines are parallel. So I would write that simply as P is parallel to Q. So can we set up a problem with two parallel lines to see something again with this? So I'm going to make a set of parallel lines. I'm going to call these parallel lines P and Q. I'm going to mark them as parallel and construct a transversal. My transversal needs to be numbered 1, 2, 3, 4, 5, 6, 7, and 8. And what I want to know is that given that P is parallel to Q, can I prove that angle 4 is congruent to angle 5 without just relying on a definition? So if what I'm after is 5 and 4 right here. So what I'm going to do is I'm going to start by saying that angle 5 is congruent to angle 7. And this is because of corresponding angles. So if angle 5 is congruent to angle 7 because of corresponding angles, I could then fall back on previous lessons and remember what vertical angles are. Now this would be a very short form in being able to do it, but then I can say that since 7 is congruent to 4, I can use substitution and say that now 5 is congruent to 4. And we've gone through a very short form just by remembering some of the vocabulary from a previous lesson. Remember, math rocks with a capital M.